All right, so now we're recording. All right, so listen up, okay? If I graph y equals x plus 3, I went over this the other day. I don't know why I get stuck on 3. And I graph y equals x minus 3. They're inverses of each other. They flip over the line y equals x. If I look at an xy chart here, if I fill in 6 right here, I get 9. If I fill in 0 right here, I get 3. What happens in this chart, I don't know if you've probably seen this before in Algebra 2. A lot of times we forget, and it's a maturity situation. And this one, if I put in 9, I get 6. If I put in 3, I get 0. Are y'all noticing what's happening? There's a word that I say a lot in my calculus class. At this level, you start to become very literal in what you're doing, okay? You've been in training, and now you kind of need to go with, this is literally happening. You can switch x and y. Y'all probably all remember that from your algebra classes. That's how you find an inverse. But the key word here is inverse function. That's what we're actively looking for, because that word function literally means what it says. I can find the inverse of anything all day long. There's no one to stop me from switching every single x and y that ever existed. I can flip them all, but once I flip them, it might not be a function anymore, right? Okay, because I think everybody, okay, so if I said, if in an assembly I'm like, like a coach, like Murray, come up here, then Megan and Grace might be looking at me like, I don't know which one. They both might come up, or they might sit and wait on the other one, or whatever. But you see, I could switch everybody's name, but that doesn't mean it's going to function very well. Like in the senior class that graduated last year, there were 2 Sarahs, but that didn't help to switch the names because they were both Sarah Sullivan. And so we still had to find a workaround. I mean, so do you see how that wasn't a one-to-one function, okay? But to find an inverse, you switch the x and y. Doesn't mean that when you find the inverse that you actually got a function, though, so just stay with me here. Does everybody see the x's and y's have quite literally been switched? Okay, we could do this all day long. We're not going to, but we could, okay? And what happens is when you have a point like 0, 3, it flips this way and becomes 3, 0. Do y'all see what I mean? Your y becomes your x, and your x becomes your y. So quite literally, back to this word, what do you notice about your x's and your y's? Since you flipped them, do you see I could say x equals y or y equals x? That's why they flip over that line. I like to tell you a lot about why things happen. All right, so if I have y equals x over 3, and y apparently still stuck on 3, if I fill in 6, I get 2. What's going to happen here? If for x I fill in 2, what am I going to get? 6, okay? Everything was fine until then, until you got that tiny disclaimer, oh, but you can't divide by 0, okay? And these, y equals x over 3 is a line that goes up 1 over 3. And this is a line that is at 0 and goes up 3 and over 1. And of course, they flip over the line y equals x. Do y'all see what I mean? The x's and y's have been switched. Quite literally, x equals y. All right, things start to get ugly, not as ugly as you thought. But let me tell you, a square root doesn't get rid of a square. Not without some intense thought on your part. And that's going to be true for a lot of inverses that you find. The only way to get rid of an exponent is to use a logarithm, unless it's just one I happen to know. What I mean by that, let's go back to something that we're talking about, like squares. If I have this, I know that one. I don't even need my calculator. I don't need to think much about it. However, do y'all see that it's physically impossible for me to answer that question?
Yeah.
How many answers are there for x? An infinite number. This one was not physically impossible for you to answer, but how many answers are there to that question? 2 correct answers, okay? So let's review a bit. When you square root x squared, you really were never getting x. You were getting the absolute value of x. Remember that? The square root of 16 is and always has been 4. So where'd your plus and minus come from that your teacher all of a sudden started saying? What could you put in for x here? Nicole, we could put in 4, or what else would work? It was traveling down the left-hand side. That was an intense conversation the other day, so you can blame any of us Algebra 2 teachers for not getting into that, but you need to know it at this point as you enter some other things. It's going to be very rare from here on out to get a function that you can just slap something on it and undo it without any thought whatsoever, okay? So think of the little disclaimers you got. No disclaimers with addition and subtraction. You got a tiny fine print, oh, but you can't divide by 0. Square roots, you got a big bunch of fine print. You left out half your numbers. You can't square root a negative. So do y'all see there's things that happen along the way? Okay, and so this, the things that could fit in here for x would be 4 or negative 4. I hardly ever, I'd probably never write that, just out of habit, because it's not plus and minus 4. It means it could have been either one, and sometimes I want one, and sometimes I want the other, okay? So what if I ask you this? I don't know what that is, so I would need you all to get out your calculator, but unfortunately, what button would you have to push?
Square root.
You'd have to push the square root button, okay? In which case, I wish every time you went to that second button that you probably haven't paid much attention to yet, usually you're actually reaching for the inverse of whatever. Look above the logarithm button.
I
What
didn't
do
even
you?
realize that.
Yeah, I didn't either. At your age. Look above the logarithm button. What do you see?
You see the exponent.
You see an exponent, don't you? Do y'all see what I mean? Look above the sign button. You see inverse sign. It's like they put them together because that will somewhat undo what you need to do. Now we are all dependent on our calculators for the square root of 117, but we better actually have a brain and know what problem was being asked of it, okay? Because all your calculator knows is that you asked it this. And what'd you get?
10.82.
Okay, 10.82 something, okay? So are you going to go to your paper and write down 10.82? No, because you have eyes and you've got the brain. This was your question. Your question was not this. Do you see the difference? Okay, your question was not a square root of x question. Your question was, what do you square to get 117? So do you need your calculator to jumpstart the problem, not to answer or finish the problem? That's up to you, okay? So there's going to be times that I get an answer from my calculator that I either add to or I override completely, but I tell it, thank you for the help, okay? Gee, thanks for a jump start, a hint as to what I need to do here. This function looks like this. There are two answers. The square root of x function only looks like this, okay? Hang on just a minute, because there was something else I wanted to say, and I can't remember what it was. Thank goodness I wrote all this down. But I still may not remember what it is. But don't forget your question, Nicole. I'll come back to you just a second. Oh, I know what I wanted to say. Absolute value of x, if you have y is equal to the absolute value of x minus 4, and you want the absolute value of x minus 4 is equal to 8. I'm sorry, I'll put writing in red, but you don't have an inverse function for that. Do you know of anything you can just slap on there, like a little symbol that somebody's made up to make those disappear? You know what you have to do? You have to handle it like a piecewise function. Because it's a function, but it's not what? One-to-one. Somewhere along the way, somebody made up the symbol for square root. There's not really a symbol for this. You have to think about what if this thing in here is positive? What if this thing, it's kind of interesting to think about, isn't it? You don't have an inverse function there. And the trouble hits when it's not one-to-one. Like x cubed. There was actually no problem with x cubed and cube root. Those do completely undo each other, but now you know more. You really can do that almost mindlessly because it's definitive if you cube it. One way to think of it is it's a function, but it's also what? One-to-one. Are y'all okay with that? The cube root function looks like this. It flips over the line what? Y equals x. Do y'all see what I mean? When I flipped it over and changed all my y's to my x's, it's still a what? It's still a function. It's conclusive evidence if I have x cubed equals there's only one thing that I could have done to make that happen, right? And I am allowed to cube root a negative. So you got to be super aware if you're dealing with a one-to-one function now, as opposed to one that's not one-to-one. Because when you take you can take the inverse of any relation of numbers that you want to. I could invert all of these numbers right here, but it would look like this, and it would cease to be an inverse what? Function. I can't stop you. Well, I won't stop you from taking the inverse of everything, but good luck with that. We're on the hunt actively for inverse functions, okay? And we're in a world of hurt with sine, cosine, and tangent, because I can't think of anything that could be further from an inverse function. Now, if I give you this, I don't know what this looks like, but you know, it could look like that, right? Is there anything you can slap on there to get rid of all of that? I can't even isolate x right now. Just see, all of a sudden I don't have an inverse function. There's lots of things that you couldn't undo. All right? All right, Nicole.
Okay, so my question was like the square root of like let's say 117 is always like the 10.8 thing, but like in the function given, that's where it's plus or minus.
You got to look at your question. You've got to look at what your question was. Is that what you're saying?
Yeah.
Yes. You've got to look at your question. More and more and more. This is just like heading into pre-calculus and calculus and things that the inverse function that we write on there, I guess the biggest thing I can say to you, and before I take Elena's question and move on, is when I give you, or not me, when anybody ever gave you a question and you started doing algebra to it, you were changing the question. You may have been changing the domain of the question, okay? If you had a square root and you squared both sides to get rid of it, all of a sudden you just gave yourself a new domain and you might get extraneous roots and all. That's why all of that was happening. I like algebra 11, but as soon as I add that first 3 to both sides, I've actually changed what someone gave me, okay? So you got to handle them correctly. It's just like, you know, me being a mom and I had a sick kid and I gave him Advil, it can help every illegal but not you. You know, and like go in the medicine cabinet, but after a while I might need a doctor. I might need somebody that knows more. You're becoming those people mathematically. You know, it's like people can add and subtract and square root and do it mindlessly, but not where you're going. You can't do that, okay? So you're becoming the professional. Elena.
So if it's not a one-to-one function, you don't have an inverse. Well, no, if it is a one-to-one function.
What we want to do is we are desperately would like something to at least give us some help to continue to work the problem. Like for instance, there's people all over the world right now that run into, they're doing like an application problem, whether it's with a satellite dish or astronauts or cell phones. And they might need to know the angle that gives them this value after doing some calculations. And so that's not one that they just know. And so thank goodness there's somebody long ago found a way, at least a sort of a workaround, okay? But there's a lot of angles that give me that, aren't there?
Yeah.
Okay, if I like drew a sine wave and I look and see how many times it hits 0.3342, but Isabel, what she did was so wonderful. Like I was really excited about what she came up here and drew that in the last class, because chances are the one they want is probably the acute angle. You know, I mean, there's times that you want to rotate a satellite dish over 90 degrees and you want to actually turn it like way over here if you've seen the movie Contact or something like that. Or if, you know, in those news trucks, sometimes you'll actually see the satellite dish. Somebody's pushed a button and they're moving it to receive a signal. And so if my calculator tells me 30 degrees, I've got to know what I'm doing. I might want to actually rotate it 150 degrees. Do you see what I mean, sort of? Okay, so Nicole's really hit on it. It all depends on how the question's asked. Okay, if I'm on this, I want two answers. If I'm on this, I guess I'll just do it this way. I'm only looking for one answer. If I'm on this function, I want two answers. If I'm on this function, except for it's 0, I'm sorry, that's why I kind of stumbled through that. There's only, if y is 0, there's only one answer to that. But think of the graph. Isn't that the only place it has 1 point? See how much you're going to know, okay? How many answers are there on this? If I start filling in numbers for x, there's only one. Your calculator, do you see you'll still use your calculator sometimes to help you with this one? You've got to know which one you're on, okay? So I'll take another question, then we'll move forward.
Okay, so I understand like when you want the two questions, but what do you mean when you override your calculator?
Just a second ago, when I asked the answer to this, x squared equals 117, you have to pick up your calculator and type in its inverse. But how many answers does it give you? One. And you have to override that with the negative option also because of how the question was asked. If you see this on your sheet of paper, how many answers do you get? Do you see what I mean?
Yeah.
So your calculator picking it up, if something's not a one-to-one function, all you're really going to be given is some help, okay? And somebody somewhere had to make a decision. Somebody decided, well, let's just look at the positive squares and flip that over and reflect that over the line y equals x. Do y'all see what I mean? Because chances are that's probably the one you want. If it's not, you can say more. That was a lot. All right, Lindsay?
So do you mean that, like, so technically, like, it can be both, but, like, when we're talking about graphs, it can only
It
be
depends on the context of the question. You've got to know what question you're being asked. If you're being asked this question, your brain has to know there's two answers to that. If you're being asked this question, your brain has to know there's only one answer to that. So I don't know if I answered your question. You want to state it again? I feel like I didn't. As I started talking and being real adamant about that, I don't think I answered your question.
I think, like, kind of. I was just saying more like, if you're graphing it, you know that it just has to be positive. Like, yeah. So
I don't think I'm talking about graphing. I'm talking about working it. I'm talking about using your calculator to find answers. Okay? Or using your brain to find answers. I mean, obviously, I think a picture's worth 1,000 words, so I'm going to talk a lot about graphs every day in here because if you that's why I keep drawing all these pictures. I could just say it, but if I didn't draw pictures, I don't think you'd see what I'm saying. Okay? If you take something that's not a one-to-one function and you try to find the inverse of it, sometimes nobody can. And sometimes they come up with a workaround. You've got to take it with a grain of salt. Every time you push that second key, I kind of wish it would go bzzz, which would be aggravating during a test, I understand that. But we'd be knowing that everybody in the room would know that you're about to be in danger. When you push that second key, you're in danger. Don't you just take what it gives you, okay? Stop and think about what your original question was. Forever, all right?
So, for like this, so x squared equals 117, and the inverse of that is x equals root 117.
Kinda, not completely. That's what I'm saying.
Right.
We have very incomplete inverse functions, and so I'll say it again. It's a lot to think about. The only way I'm going to have a complete inverse function is if the one I'm trying to undo is one-to-one. Addition and subtraction was about your last stop there a long time ago. You got a oh, but in division. Does division completely undo multiplication? Then you got a big, but wait a minute, on square roots.
So it's like half of the inverse.
Right now, division just left out a dot, okay? Square rooting left out a whole lot, and I think you're starting to see, Elena, that inverse trig functions are going to have to leave off even more.
Yeah.
So what we've got to do is find a way to answer the question that will help everybody the most, okay? All right, but let me move on, because we could spend the next hour on this, and we got to keep moving, so we got to look at our trig functions. Okay.
Yes, do you want the x and y value or just the x value?
Oh, good. Okay, I'm not counting all for it, but I'm writing on people's paper, and next time I'll count off. When it says
Okay.
value, they just want the y.
Just the y?
Just the y. You'll probably show like all your little fill-ins,
Okay.
and then.
Okay.
Okay. So here we go. All right. So I've got the calculator pulled up, ready to go, because a lot of times I don't like waiting on it. So here's sine, and I'm going to come down and turn this off. This is inverse sine. Life would be wonderful if I could just have a button where I went inverse sine and could find anything I want to. Y'all realize that's not going to happen. I could be working in a problem, and I can know I have an angle in a certain location. And I might have to use the inverse sine button because I don't recognize the ratio to find the angle. But it might not give me the angle that I want. Okay? All right, so here's sine in radians. Okay? That's a function. Everything's great. Is it 1-to-1? Heck no, right? Okay, so with our calculator, we've got this super cool key that you don't need to know. I'd rather you kind of almost not know it. There's a button that I can push that says draw inverse of what I put in Y1. Notice the words there. Does it say draw inverse function? No.
Because it's not.
My computer is a function, but it's not
A
1-to-1. So all it's about to do is switch all the x's and y's, which should reflect it over the line y equals x, right? So let me go back to y equals, and let's turn on the line y equals x, so you'll see that happen. Okay? So we're about to see something reflect over the line y equals x. All right? So here it is. So now I'm going to get to draw just the inverse and not the inverse function.
Whoa.
Okay? Did it flip over the line y equals x? Is the blue? Yes. Oh, y'all okay with that? I didn't hear a resounding yes, it did. It's really pretty. Is that a function?
No.
Notice the domain and range have been flipped because you flipped x and y. That's why on your homework they give those little charts to graph from -1 to 1. Did y'all realize that? And your answers, I don't know if you recognize them, were things like pi's and pi/2's. You may not have recognized the numbers, but you probably recognized 3.14 at least in your exercise. So what they were having you do was now all of sine and cosine ratios are from -1 to 1. Okay? So the only answers I can get are from -1 to 1, and now I'm looking for the angles. Do you see the difference? So the ratios, my input here will only be -1 to 1. But what if I put in arc sine or inverse sine of 1/2? I would never use my calculator again. So we got to pick a little sliver of it to at least give us some help because people really need this stuff. We can't just go, I don't have an inverse for absolute value. I can't do that with sine, cosine, and tangent in the world we live in, okay? So, and by the way, the choice was made hundreds of years ago before technology. So the funny thing is what they decided years ago that Isabel came up and drew on the board. Our brilliant 2019, almost 2020 technology doesn't negate that. It's still all here. Okay? It all of a sudden, thank goodness we had it because then they could program calculators the same way. So this is what she did. Or this is what your homework looked like. Let me turn this on. And when you graphed arc sine on those little 3 graphs, yours should look a lot like this. But I've got to turn off the inverse. All right, y'all ready? You're not supposed to be punching, you're just supposed to be watching because I don't want you to miss something while you're looking at your calculator. Okay? So I'm going to turn off the green. The green is the sine graph. Now, how much of the x squared graph do you get when you do square root?
You got
Half of it, would you agree?
yeah.
Okay? You get a pitiful little piece of the sine graph. Do y'all see that? That's kind of, I'm sorry, it's yellow again, but That little squiggle should be what you did on your homework, okay? I'm gonna turn the green one on again, and you'll see that what's happening is the inverse relation's going like this, but this is the only little piece I get because it's a function. Do y'all see? As soon as it turns that corner, what does it cease to be? Function, okay? And so it's part of that little S going up the graph. So we'll look at that. Look at the yellow. Let me get rid of the pink line. All right, look at the little yellow. Did y'all see how it went through it? Some of y'all didn't see that at all. But those of you that were looking, you saw it, didn't you? Did you see it just go over the yellow part? Okay, we get that little sliver because it's all we can get. All right, so I'm going to kind of speed through this now that we've talked about it so much because we got to get some problems done. Hang on. Please don't forget your question, okay? So here's a sine graph that goes on and on to infinity. Okay. The ratios can only hit from -1 to 1 because of opposite over hypotenuse stuff, okay? But if you take the reverse of that, by the way, a side note, if you're ever looking for this, stop. There's no way that can happen. There's no way the opposite over hypotenuse can be that, is it? Has your sine graph a picture's worth 1,000 words? Has your sine graph ever gone up to 3 with the amplitude of 1? No, that one's undefined. There's no angle that's going to ever do that for you, okay? And so what happens is Isabel came up here the other day, and she drew this piece. It makes sense to stay around 0. I mean, Isabel could have come up here and done this. But what are the chances somebody wants something from like -270 to 300 and something? Do y'all see what I mean? Okay? So, she came up here and drew this piece, which takes care of every -1 to +1. At least I'm going to get some angle to get me started. All right? And that's inverse sine. That's all you get. Inverse sine goes from -π/2 to +π/2. Now we're going to go to cosine. Even if you have questions, we're moving on. A lot of your questions will go away if I keep going. If I know that I love to talk about the theory behind things and show you lots of pictures, but if I keep going, it will become clearer. I want to do this quickly, but I do think it's valuable. I want everybody to look at my horrible picture of cosine and just pretend like I drew it correctly, where the little maximum is actually at 0, 1. Okay? Do I have any volunteers to guess what they did for arc cosine? Do you think you could draw it on there? If you were in charge, you're the mathematician hundreds of years ago, to go, well, I can't give them all of that. What logical piece would you pick? Anybody, any volunteers? Chloe, you want to draw? Because Chloe, as a mathematician, the best thing she could do for us is give us a way to find positives and negative ratios, right? Is this a different color? Yeah. Yeah.
So from here to here. I don't know if that's
Okay, so Chloe, why do you think that won't work? Did you give me a way to find any negative ratios? Because sometimes isn't sine like a cosine like -1/2? Also, I guess the biggest thing there is it's a function. She's right about that. But girls, hang on, listen and think about this, Chloe. Thank you for your bravery. It gets us started, which is what I want. Now all of a sudden, once you did that, a bunch of hands went up. Okay, it's because you got us started. Girls, that's the cosine graph. I haven't flipped it over yet. If we flipped over that red part, are we going to have a function? If I switch X and Y of that red part, I'm not going to have a function, so I don't have an inverse function. I want an inverse function. Function meaning it will work for me. All right. Oh, a bunch of hands went up. I don't even know who to pick. Pietra, do you want to draw?
Yes,
Chloe probably already has like another idea. I'm going to hit the undo button.
Rebecca, that was
Is that what a lot of y'all were wanting to do? what you were wanting to do? Okay. Thank you. All right, now, couldn't Pietra had come up here and done this, and then she'd be being Mr. Hell, just intentionally aggravating me, be going, okay, yeah, you could pick that one, okay, but why would you do that? Chances are most people want to deal with something from 0 to 180, or in radians, this is pi. Because at least it gives me a jump start in the first and second quadrant to get some help. That's all we're given, okay? Again, it matches actually with that little picture that you had on homework like this. So one of your homeworks, I actually think cosine was the first one they gave you.
Yeah.
Okay. Now remember, this is the flipped over version. The x's and y's have been switched. And you probably had something like that above the axis, okay? That's because I'm looking at the cosine graph, trying to flip that over. So let's look at that for a minute. This point was pi negative 1. So if I switch the x and y on the inverse, doesn't it become negative 1 pi? So if I graph the point negative 1 pi, I get something like this, and it comes down like that. If I switch all the x's and y's, and you probably have a picture like that somewhere on your paper, okay? You are not going to have to graph inverse functions, inverse trig functions. You're just going to have to understand them, just to settle you down some, okay? But it is important that we all talk together and that we're brave about picking it instead of me just showing you. I think it makes a whole lot more sense to take the time for y'all to digest it, okay? So now tan looks like this, from negative pi over 2 to pi over 2. And we have these asymptotes in here. And I think we'll just do this together. Wouldn't it make sense just to pick one of these? Like when I push inverse tangent, it's never going to tell me about these angles out here. It's just going to pick something right in here. Okay? So that goes from negative pi over 2 to pi over 2. What you'll start to notice, I give you more information. Sine and tangent share a lot more properties than you think they would, and cosine's kind of always the little Olaf odd guy out, okay? Like cute as can be, but kind of weird, okay? So that's because sine and tangent are odd functions, though. Don't they both go through the origin right here? Do y'all remember odd functions? Cosine's an even function. So get used to that. Cosine kind of marches to the beat of its own drum, all right? All right, now get out your memo page and we're going to write all of this down. Of course, you're going to let me write it first. You're going to look at it and listen to me while I talk about it. And then you'll be good to go. So, before I start, get your calculators out and put it in degrees. And just sit there with that while I do this. All right, so inverse trig, keyword here, functions, okay? How will it function for you? Inverse trig functions, inverse sine, inverse tangent, can only come from quadrants 1 and 4. They go from negative pi over 2 to positive pi over 2. You're not writing yet, I'm just talking. Don't write yet, okay? Didn't sine, Isabel's little sliver went from negative pi over 2 to positive pi over 2. And for tangent, I picked the same thing, okay? So the best way to say that is, you know your quadrants are coming at you. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. This is negative pi over 2, solidly to pi over 2. This is negative 45 degrees. This is positive 45 degrees. Do you see how I can only go from negative 90 to positive 90? Isn't that what I'm showing you here? Okay? So I'm talking about from negative 90 to positive 90. All right, now arc cosine does this. That's not good. Okay. Arc cosine does this. It went from 0 to 180, didn't it? 0 to pi. That's what 2 quadrants. 0 to pi. You're only allowed to pick from 1 and 2. You cannot go in these people's yard. They will call your mother, okay? You cannot go in these people's yard. I don't care how bad you want to get in the 4th quadrant that way. You just fell off a cliff and you're not with us anymore, okay? You're still falling off the cliff while we're trying to pull you back up and get you back with us, okay? The way to get around this is to go here or here. All right, so let me write this a little better and then you can write it down. The way this would show up on memo quizzes, not the next one. The way this would show up on on memo quizzes is I would just write inverse sine, and you would write quadrants 1 and 4. That's all you got. You got to tell me you know what quadrants you're coming from. All right, here we go. Memo page. Well, you're not even gonna have a memo quiz next class. We've had a lot lately. After you write that down, your calculator's out and your first homework sheet. That's probably wrong for a lot of people. Okay, hurry up and finish. Or if I move on, you know where it is in the slide. All right, moving on. If you want to meet with me to make sure your memo page is right, that's fine, because some people are being so precise. All right, I'll be glad to help you get all that down later if you didn't get it just then, or you can fast forward to this point in the video. Calculator's out, and that worksheet on inverse trig functions, I gave you 2 classes that I checked last time. Yeah. Okay, so everybody's calculators in degrees. Type in inverse sine of the sine of 47. I'm sorry, By the way, whenever you push inverse sine, what are you wanting? What are you looking for if you're pushing arc sine? You've got the ratio, you're looking for an angle. A lot of you are wondering why I'm even having you punch this in your calculator, because up until last class, girls, y'all probably thought this would happen. Right? Just like you thought that this would get rid of that and you would have x left. You don't. You have this left. Now, just then you did get 47, didn't you? Yes. Okay. Now push inverse cosine of the cosine of 30. Still good? So I haven't convinced you. You can't just do like what you thought was happening in your previous life. Okay? Now push inverse sine of the cosine of 60. What'd you get? Do you know why? What's the cosine of 60? Cosine of 60? They're cofunctions, but the cosine of 30 is 1/2. And so your calculator found the cosine of 60, and then we're looking for an angle that gave you the same sign. You're asking what angle would give you a sine of 1/2. Y'all see how there's a problem to be worked out? Now type in inverse sine or arc sine of the sine of 270. You will not get 270. You'll get negative 90. Is that correct?
Yes.
Because it's a math problem to be worked out. When you figure this out, you get negative 1. And then you and your calculator are actually realizing, well, I can either go here or here. I don't want anyone to call my mother, and I don't want to fall off a cliff. So, like, I'm sitting here going, ooh, I'd really like to go around here and see whatever's that way to get to this location. I can't do that.
So it's
I
like
can either go up to 90 or down to negative 90. And so that also answers the question. Do y'all see what I mean?
Yeah, so it's like the F of the H.
It is. And it's a math problem to be worked out just like this, girls. I hope you know the answer to that is the square root of 9, which is 3. So obviously what I'm telling you is true. This doesn't just get rid of that. The answer to that cannot be negative 3. The answer to that is 3. You got to think about what you're doing. There's a, like Elena said, it's a composite function. There's a math problem to be worked out. We can't just mindlessly start canceling things out anymore. We've got to actually think about what the math problem's asking. Let me show you what'll help. Whenever you see arc sine or arc cosine or arc tangent, you might want to make a little note of the quadrants that are applicable or a little picture. As soon as you see this, before you even look over here, you know you've got to go here or here. All right, so arc cosine of the cosine of 240. Those don't just cancel each other out and you get 240. I bet you get 120. You get 120? Okay, this is what just happened. Arc cosine can come from quadrants 1 and 2 only. Okay? Pietro got up here and went from 0 out to like 180. It can only come from quadrants 1 and 2. I know the cosine of 240 is negative. So do you see that it is at least helping me with a reference angle? Okay? All right, now get out your page that you did on your calculator, and I'm going to do it by hand. All right? Correct your answers, but this should be where we are today. All right? Bella? Yeah. Okay, number 1 is arc sine 1/2. Let me make sure I have the right worksheet. Is that how you're started?
Yeah.
All right, it can only come from quadrants 1 and 4. But that's kind of a no-brainer. 30 degrees pops in my head. It's appropriate. I want you to know you are not answering this question. Okay? You're just getting a start on this question. How many answers are there to this question? Which, by the way, I'll teach you how to answer them. Okay? There's a way, and you may go, whoa, how can I give you an infinite number of answers? What if I said, Brianna, when's your birthday? Okay, she didn't say August 16th, 2000, when were you born?
2003.
She didn't go, like who went to the party when my parents asked. Brianna didn't roll her eyes and go, okay, August 16th, 2003, August 16th, 2004, August 16th, 2005, August 16th, 2006, August. Do y'all see what I mean? Like I know when her birthday is, I got it. It's a pattern on my calendar. So do you see I can teach you a way to answer that? When's Christmas? Do you have to, I don't even know who decided that, how many hundreds of years ago, and into the future, they'll still celebrate it, and it's like, I got it. You'll have a way to do that with this, okay? Don't worry about it now. Let's move on. Arc cosine of negative 1/2. Your calculator, you may not have trusted it, but it was right. Arc cosine can come from quadrants 1 and 2. This is a negative ratio. Do you see I've got to go into quadrant 2 and pick the appropriate angle, which would be 120. Okay? Cosine's negative in a lot of places, but that's all you say with this, just like with this. You just say 5. Arc cosine of 1/2. You really are just saying the first thing that you encounter, and then you just stop. Arc cosine of 1/2 would be 60. Everything's pretty easy in the first quadrant. Number 4, do y'all have arc tan 1? Arc tan can come from quadrants 1 and 4. It's positive, so I just have 45 degrees or pi over 4 radians. Number 5, arc tan negative 1. Okay, it can come from quadrants 1 and 4. How are you going to get into quadrant 4? Are you going to go around? You're going to go right down this way, okay? So the answer your calculator gave you, my guess is negative 45. I saw a couple of you trying to override the process on your homework and wrote down 2 answers, but if you're going to start that, you're not going to ever stop that. 2 answers isn't right. Why not write down 85 answers? Do y'all see what I mean? Okay. The next one is arctan root 3. And I would run into that at 60, or pi over 3 if we're in radians. Arctan root 3 over 3, number 7 is 30 degrees. Let's go to number 8. Number 8 is arctan of negative root 3. All right, would I find it in quadrant 1 or quadrant 4? So it says negative 60. Is that what your calculator gave you when I just had you go home and punch? Okay. You only give one answer if it's written like this. All right. Number 9 is 45 degrees. Number 10, arc sine of negative root 2 over 2. You're going to find that in quadrant 1 or 4. And so negative 45 degrees. Number 11 is 30 degrees. Let's go to number 12. Number 12 is arc cosine of negative root 3 over 2. People that not of your training would just have walked in and maybe think every time I get a negative answer, I get a negative question, I get a negative answer. That's not what's happening here. There's positives and negatives in all sorts of different quadrants once you leave quadrant 1. I'm only doing it because I'm in the appropriate quadrant. Arc cosine can be in quadrants 1 and 1. 2. You know what is interesting is in quadrant 4, cosine's not even negative anyway, is it?
No.
So that's not going to be helpful. So we've got to travel over in here at a 30-degree angle and say 150. Okay? So to sum it up, when you're given an inverse trig function on your piece of paper and it's your question, you give one answer, if any. If I ask you for arc cosine of 5, there's no solution to that. If you punch it in your calculator, it'll say error. But I just gave you a ratio of 5 over 1 for cosine. Can that happen? What's the biggest thing arc sine and arc cosine can be? 1. Think of your graphs. Now tangent can be 5. Tangent can go up to where? Infinity. All right, so now let's look. I'm going to the book. And I'm at page 322 of the book, which I know none of you have your books here, but let me point this out to you. Back in your book, these, you may be kind of mad if I'm showing you this, but these are the pictures you had for homework, okay? Do you see how the sine waves coming like this? Okay, so these are the 3 like problems where you were graphing points were right there. That's page 319. You will not have to graph those for me on my test. I don't know what Mr. Hill will ask. They won't be doing bicycle problems, so it's all fair. All is fair. All right, so I'm going to just crank out a few problems and then talk about what your assignment is. Sorry I kept flying through that, but we finally made a lot of headway because we got to start working problems and stop talking about theory. All right. Okay, on your homework, you're going to see some problems like this. Arc cosine of x. Okay, now I can answer arc cosine of 1/2 is 60 degrees. Wait, hang on just a minute. I don't know if I want to do that one or not. 37. Okay, yeah, I won't give you those. I would give you more one like this. Let's do this one first, and then I'll do one with x in it. All right, so now we have composite functions. The inside's asking you for an angle, of which you don't even know what the angle is. I don't know what angle gives me an arc sine of negative 3/5. Once I find that angle, I've got to find the cosine of it. Do y'all see what I mean? Okay. I can actually answer that question without my calculator. What quadrant have they put me in from the beginning? Inside out. Where can arc sine be? Quadrant 1 or 4? Arc sine quadrants 1 and 4. Okay? Which one are we in? 4. All right, so I'm down here. That's why I have negative 3 over 5. Do y'all see what I'm doing? What kind of triangle is this? A 3, 4, 5 triangle. So I don't even know what this angle is, but I can find the cosine of it, can I? What's the cosine of this angle? Adjacent over hypotenuse? 4 over 5. All right, now you might want to put it in your calculator. Why don't you do it? You have it out. Push that in your calculator and see if you get 0.8, which is 4/5.
Cosine.
Type that into your calculator.
Yeah, okay.
You get 4/5, don't you, Katie? 0.8 is 4/5. Okay? So what your calculator did is it worked it from the inside out. All right? So that's not bad. You'll do some of those. And you can even, here's something interesting, girls. I actually answered a question like this without ever finding the angle, which is kind of interesting that you can bypass that. So what are you going to do if you see something like this? Arc sine of x over 3. All right, now that seems very vague, like, oh my gosh, what am I going to do with that? All right. First of all, you don't know what quadrant you're in, do you? Arc sine can be in quadrant 1 or 4. I'm going to show you it doesn't matter in just a minute. I'm just going to throw it in quadrant 1 for now because I don't know what x is. So if in quadrant 1, opposite over hypotenuse, couldn't you do the Pythagorean theorem to find the missing side? Y'all okay with that?
Yeah.
X squared plus, let's say, y squared equals 9. So y squared is 9 minus x squared. So y, remember when we square root, I've told you y, you say plus or minus. The square root of 9 minus x squared. All right, now do you see that we have a dilemma here? I'm sorry, I shouldn't have used y there. That's really bad on my part. Because I'm actually looking for, boy, this is, I'm sorry, I didn't think about this happening right here at the end. I have to call this x, but it's really a vertical component. So I'm going to erase this for a minute. It's not really good of me to use x's and y's because do you see I was really actually looking for this side? So that's probably misleading. Let's do a squared plus b squared equals c squared. All right, so I'm going to say a squared plus b squared equals c squared. A squared equals 9 minus x squared. All of our intense talk is going to pay off right here, right now. A is equal to plus or minus the square root of 9 minus x squared. I know which one it is. I've got a picture. Arc sine can only be in what quadrants? 1 and 4. And I actually know what this missing component I'm looking for. I can see it's got to be what? Positive. So plus or minus comes into play right now. I got to pick one. So I know that it's the square root of 9 minus x squared. Did y'all see what I mean? Now can you finish answering the question? Cosine, what this does is it got everything for this angle that you need. I don't even know what this angle is, but ironically I can find the cosine of the angle that I don't even know, okay? What's the cosine of that angle? Adjacent over what? Hypotenuse. Do you see it didn't matter if I was in this quadrant or this quadrant? I was going to get the same answer either way? Okay. Now, let's backtrack a bit. What if I have sine, arc, cosine of square root of 3 over 2? We could do it this way. I could go arc cosine, oh, that's in the first quadrant, square root of 3 and 2. I could do the Pythagorean theorem and I would get 1. What's the sine of that angle?
1 or 2.
Okay, but couldn't you have also found the angle and done it that way?
Yeah.
This would be arc cosine of square root of 3 over 2 is 30. What's the sine of 30? Do you see that all of that works, okay? If you don't have the ratio, do the Pythagorean theorem. So I hadn't posted the homework yet. I didn't know how far we get. And remember, test is November 22nd, okay? I may also attach a very short video to help you with some of the homework. I haven't decided. But I'll decide in the next hour, okay? Oh, we have chapel, don't we?
Yeah. No, we have it second though. We have it second.
Oh, I have chapel. That would be me.